All right, so I want you all to quickly turn on with your videos so that we can start with the webinar and we can have an interactive. Yes, great. Hi, Pallavi. Others, if you are in a comfortable seating, come on quickly, turn on with your videos. All right, great. Okay, so hello guys, welcome to SkillVertex, and this is our webinar series named as Skill Connect. I am Shavni. I am going to be the host and also the mentor. His name is Nitish. I'll be explaining more in this webinar. Before that, I want you to know about SkillVertex. So we are a growing edtech platform focusing attention to upskill the youth of today through a plethora of various programs made available online. All right. So SkillVertex also emphasizes on the needs and future aspirations of the individuals, connecting them to the emerging industrial technologies and requirements. So we are a place where students entrust us, where the skills are nurtured with personalized mentoring directly by the industry professionals who mold the students into skilled craftsmen of their domain and assist with the career guidance as well. All right. And we also focus on incubated development. So when it comes to your career, no question should be left unanswered. And hence presenting to you Skill Connect, an online series of interactive knowledge sharing webinars that covers most of the prominent topics of your favorite field. This webinar from the series is on the booming topic of master the data structures in Java from arrays as well as trees, hosted by Nitish. Okay, now talking about Nitish, he is a CTO at Qubits Learning Software Solutions. He has his expertise in data science and web development. So he has worked in Python, Java, C++, JavaScript, tech stacks, and his highest education is MCA. He's an MCA as well. So yeah, that's about it. I will, take it over, hand it over to Nitish now. So welcome, Nitish, and yeah.
Yeah, thank you, Shravani. So, welcome everyone to this webinar. I will be your mentor. Will I'll show you why exactly is this. Just this thing. Okay. So let me share my screen first. Just okay, so hopefully my screen is visible, right? Right. No. Yeah. Okay. So in this webinar, we will learn all about data structures in a specific programming language, that is Java. Now, we have chosen Java because if you see the other competing programming languages like Python or C, it is not that definite. It is not that defined. In Java, we have a good base for all these programming languages. Sorry, all these data structures. Okay. So first, welcome all of you, and I hope you have a basic understanding of a programming language. You know what Java is and how things work inside a programming language. Okay, because that is needed for us to understand how data structures work. Okay, so let's get started. Okay, so in this session, we will learn about first the introduction to data structures, what is data structures, why do we need them, and all those things. And then we will follow it up with two kinds of data structures, that is linear and non-linear. We will see all of this, why one is better than the other, why, what are the use cases for each and every kind of this data structure. Okay. So first, what exactly is this data structure? Now, as the definition suggests, it's it's more like a rule or a format for which you can arrange and retrieve items where you store it. Now, why is this required? Because if you have started learning a programming language, you all would have learned about variables, right? Which can store one value. But sometimes one value is not enough. Even most real world use cases, you're not going to store just one value. You're going to store values related to this, a sequence of values, a whole list of things. So all these real world use cases cannot be used with just variables. We need something bigger than variables. So that is where the concept of data structures come in. Now this structure, it is not exactly a, you know, a software or something like that. It is more like a set of rules, because this same rules you read in Java that can be used in other programming languages like Python or C. It can be used, but it is predefined, it is properly defined in Java. That is the reason we are choosing Java as the base for these data structures. Okay. So I want you guys to think of a big bag. All of you guys would have traveled, right? Think you're carrying a big suitcase. Now, if you randomly throw in items in the suitcase, next time you suddenly want to retrieve a shirt, how would you do it? You should open the suitcase. You should first use your eyes and hands to search, right? If you throw in randomly, that is first time consuming. It will not achieve the goal efficiently. So instead of that, we can have some rules as to where each and everything should go. If we already know that, for example, I put all my pants at the left side, if I already know that, then I don't have to look at my bag, right? If I can just open my bag and take a pant because I already know it is on the left hand side. If I already know all the shirts are on the top, then it's easy for me, right? So that is the logic behind making a data structure where we define how things are stored. So next time we want to search through it or we want to retrieve a specific thing, we want to understand what is there, that becomes easier and efficient. That is the biggest thing you have to understand, the efficiency. Because in real world use cases, right, you have all the social medias today. Think of any social media, you interact with your data, right? For example, take Facebook only. They have a lot of data structures that are running between their database and you. It's like a data structure is responsible for retrieving. It will take the data from a database, put it in a specific data structure, and then it is showed in your UI. That is the whole sequence of things that happen. If that intermediary sequence of putting things in a data structure is not there, then Facebook will not be able to do things so efficiently. It will take a lot more time for us to understand how data is moved around. So all these things are all, you can think of it like protocols or rules or formats. It can be used across all programming languages. The data structures that you will learn today, they are there in Python, they are there in C++, they are there in even the most newest latest like programming languages like Golang, Ruby, anything. They also have these data structures. It is very fundamental at today's time. It is not specific to a single programming language. It is more like a concept. Okay. And even all of these things, okay, just I think it's zoomed in. Yeah. So one thing you have to understand is they are all built one after the other, right? Everything didn't come at the same time. Like even if you take Java for instance, when Java was released by Oracle, or I think it was Sun Microsystems, right? They did not have these many data structures. Even before Java, the programming languages which came before Java, they had a single data collection structure called list. It's not the same as the Python list. Okay, it's a different kind of thing where things were just stored randomly in your RAM or registers. Data is just stored, and this list will just have a collection of these addresses of where all this data is stored. It's like a telephone book. You know, using the telephone book, you can know where a person. Not talking about telephone books today, the old yellow pages, right? You might have seen those things. So you can see where a specific shop is, where a specific address is using a telephone book. That is how lists were there. This is before any kind of data structures were invented. Okay, this is prior to Java, like in the days of C and F programming languages. That is how it was. But this is not efficient, right? Because we're adding so many layers. Today, in today's time, we don't use yellow pages books because that is not exactly efficient. It is not able to store thousands of people, not even thousands. In a city, there are probably millions of shops. You can't sit around and search every shop, and if a shop changes, you print a new yellow book. That is not right, right? So we have, in today's world, we have moved on from the yellow pages way of searching something. The same way, even programming languages, it started with lists, but today there are so many data structures that what I teach you today is not the overall limit. There are so many data structures above this also, but these form the base for everything that is there. Okay, so that is why we need data structures. Now these 4 points that I've written in the definition, like arranging, processing, accessing, and storing, this is the use of data structures. right? I can give it the example of a big luggage bag. Now, the thing is, say you're suddenly caught in something. You need a pen. Think you need a pen. You need to remove a specific pen from your entire luggage. How long will it take if you just put things randomly in your luggage? You have a big luggage and you put randomly, and finding a pen in that luggage is a lot of time, right? Instead of that, if I already know that my pen is going to be in this slot, I can just go ahead and remove it, right? So that is the logic we are going to use today, where we will see why this specific structures help us in making things efficient. Okay. So first, in this data structures itself, there are two main divisions: linear data structures and non-linear data structures. Now I know from the name, it is a bit obvious like what they are, right? Linear data structures are something that is stored one after the other or sequential. Now it might not just be one after the other, it can be one below the other, one above the other, anything, as long as one is followed by the next data. Now I want you guys to think of, for example, I want to store 10 students, like all these 10 students in the webinar today, I want to store them. If I write in a pen, right, how will you note it down in your books? You will not write one name in one page, then one random page, you remove, you write another, and you are not going to do that. You will take a single page, you will write the names one below the other, right? That is how anyone will write 10 names. The same way, this is the most basic and useful way of noting down data, where we write things one after the other. Okay, all these data structures that are seen in the screen today, arrays, stacks, queues, and linked lists. All of these four are based on the same rule, where everything is either logically or physically stored next to each other. Okay, but there are differences between all four of them, which we'll look into it. So apart from linear, we will also learn two basic non-linear data structures, which are more logic oriented. They are not exactly there to store things one after the other. These are data that have a specific different kind of meaning. Okay, not just a collection of data. That is when we will use non-linear data structures. So one thing I want to say is there is no much advantages and disadvantages. Okay, it's not definite disadvantages or advantages. It's more about which you want to use in a specific use case. That is where you will use. It's like in one use case, array might be better. In some other use case, a queue might be better. So it's up to you to pick a specific data structure according to the use case. And that will be what is required as a programmer, right? Because just learning a bunch of code is easy. I just 4 or 5 lines, I can memorize it and done. But applying your logic and understanding which data structure you have to place where is what takes the skill as a programmer, right? So that's why we will learn the advantages. First of all, we will learn why this specific data structure should be used. Okay. So first, let's start with arrays. So all of you, if you're going to any language like C, C++, Java, Python, any of this, you would have heard about arrays. It is the most basic data structure. Now, what is an array? An array is just something which stores data exactly one after the other. In your physical computers, right, in your RAM and your registers, there is a set of registers. Like say, for example, there are 100 registers. If you make an array, if you want to store 10 items and you give Java that, look, I have 10 items, I want to store this in an array. What Java will do? It will put 10 items exactly one after the other. If the first item is at memory, say for example, 100, let me just use a pen so I can write something. Okay. So if there are, okay, this, just think this is your RAM, okay? In this same photo, think this is your RAM. If I want to store 10 names right now and I make an array in Java, Java will put the first name over here. And for example, imagine this location is 100. Imagine that. Then this next one will always be 101. The next one will be 102. So this gives us advantages, right? If I want to know what is the sixth one over here, I don't have to go and look at the actual memory because I can just do 100 plus 6, right? 100 plus 6 will give me the sixth one. because everything is stored one next to each other. So that is the advantage of an array. Fast retrieval, where if you store an item in a list of items, you can retrieve it fast. That is the biggest advantage of an array because there is no extra things. What about a disadvantage? The disadvantage is the availability of memory. Maybe your RAM does not have continuous 100 memory locations. 10 is easy. What if I want to store, what if Facebook tomorrow wants to store all its users in array? How many users do you think Facebook has? I guess are there 100 million or 200 million easily. They're not going to have 200 million memory locations in their RAM, right? That's a lot. So arrays fall down when you have a lot of memory not available in your physical memory. So you want to store so many things, but maybe that much continuous memory is not there. That time arrays will be not easily usable. Even Java will throw errors that much that is running out of memory. That is what your JVM or your JDK will throw the error when you try to make an array bigger than the available memory. So this is the disadvantage of array. But if you are storing something small, like say 10, 20 items, it is extremely fast to retrieve like fifth or sixth item. If you store 20 items in an array, easily you can retrieve the fourth or fifth item compared to every other data structure. That is the biggest advantage of an array, right? Because the computer is not doing too many instructions. Like for example, if everything is stored in its own memory location, right? If I let me just clear everything. Okay. Yeah. So for example, say this is stored in like 100 in other kind of data structures, and this is stored in like 2000. And maybe the second one is stored in like 1, 2, 4, 5, something, 1, 2, 5, 6, something, some memory like that. Now the computer has to go and check, right? It has to go to its yellow pages book and it has to check, okay, the second element is in 1256. Third element is in 2000. First element is in 100. This is time consuming for the computer. This is not easy. This is not fast. Instead of that, we store everything next to each other so it can retrieve any element as fast as possible. That is the advantage of an array. So when you have the use case where you're storing less number of data, but you're storing, you want speed. Speed is of the essence. That is where we will use array. Now, when it comes to real world use cases, arrays are the most common data structure used in data science. Like when we convert images, right? When we make an image is represented as an array of pixels. Every time in any programming language, you go to Python or C++ or Java, if you're working with image processing, they're always prefer to use arrays because it is continuous memory, and that is what a photo is. It is pretty much a continuous memory of pixels, right? In your computer, an image is just as a sequence of pixels. So if you represent a sequence of pixels, the fastest way and the most efficient way to represent this sequence of pixels will be an array. So that is the most used data structure in today's industry. You go to anything, you go to web development also, where we retrieve items in a bigger list, we always use arrays. And in data science, we again use arrays, like I told you, in image processing and labeling and all these things. Arrays are fast. That is the biggest advantage. Okay. Now, so that is arrays. Mm, yeah. So, so that is our first data structure. Now the second one is called a linked list. This is something similar to an array. Now you see in array, every data can every this item, right, which is there on the screen. I think I'll show the laser pointer here. This specific location will store just the value, right? Whatever value I put over here will store that. But when it comes to linked lists, every location will store two things. It will store the value and the location of the next value. So that is the difference between a linked list and an array. And linked list can be of many types, right? In today's, after, since the day linked list was presented, after that there have been so many updates and so many new kind of things that there are many in today's world. There are many different kinds of linked lists, but we will look at the basic version, which is every element in a linked list will have two values stored in it, the actual data and the location of the next data, right? So this is the difference between a linked list and an array. Now, why do we have to use linked list when we already have arrays, right? Now think about the disadvantage of arrays. You might not have that much continuous memory in your RAM or your registers. So that is when linked list comes into play. So here we are sacrificing speed for capacity, for quantity. We can store a million things in the linked list, but we will not be able to, of course, retrieve things that fast. But it is possible. The quantity of memory that can be stored in a linked list is way more higher than an array. Okay, so that is the advantage of linked list versus the advantage of an array. Now, the disadvantage of linked list is obviously the same advantage array had, right? Speed, because the computer is doing something above just storing things. It has to also find out every time where the next element is, right? Now, if I want to say this linked list that is there on your screen, if I want the third element, I will just say Java, go and fetch me the third element of this linked list. It has to first go to the first one. It has to go from the first one. It will find out where the second one, right? Then the second one, it will find out where is the third one. From the third one, it will take the value and it will show this is my third element. So that is how linked lists work. And always the last memory will point to null, right? Because that doesn't have anything. So the last memory in a linked list, the address of the last thing will be null. That is how we can identify a linked list in if someone gives you a question like identify two kinds of data structures, the difference will be the last memory location will have null. Okay, this is pretty much a question that is always asked in like interview or something like that. So this linked list, every individual element in the linked list is called a node. This word, I want you guys to familiarize with this word because most other data structures will also use this word called node. Okay? A node is just a word for a single data point. So we use these nodes everywhere, not just in linked list, not just in, it's not there in arrays. Basically, arrays, we just call it elements because every element is not individual, right? It's just a part of a bigger thing. But in linked list, each and every element can exist individually. And the biggest thing is we do not know the place where elements are stored. It can be random. It is up to Java's allocation, memory allocator, where it wants to store anything. It is not up to us. If you are working in a language like C, then you do have control to store this thing because C is not automatic, right? In C, you have to manually give the memory where you want to store things. But in Java, there is something called as a garbage collector and automatic memory allocator. So this puts elements wherever it wants, and then it will make the list of these elements. Now, this is very similar to the yellow pages things I gave you, but the one key difference is it is a collection of things. So we don't really care about what the fifth or sixth element is. The fifth or sixth element only makes sense from going from the first one. So it has to always go to the first one, second one, third one, fourth one, like that. It will go in a sequence. So that is why linked lists compromise on speed. But the advantage they give is the ability to store many things at a time. Okay. So that is the first two data structures. Now we have solved the case, right? Wherever we want to use linked arrays, we use arrays. And where we don't care about retrieving things fast, we use linked list. Now, in reality, we have used arrays in, for example, retrieving a person's details, right? If we are retrieving like 10 people, take an example of an e-commerce website. If I want to retrieve the list of 10 people who bought this item, I will use an array because those 10 people will somehow be linked to each other. But if I want to find out when all this item has been sold, that is a lot of memory, lot of data, right? For a common item, you take some common item on Amazon, it might probably be sold like a million times. If I want to retrieve all the dates this is stored, I am not going to care much about speed, right? Because I want the actual data. This is when linked list can be used. I'm just giving you an example where you will choose one kind of data structure. And we have implemented this in practicality. right? If you go into Python and you, not Python, sorry, if you go to JavaScript and you make a web development application, in the backend, JavaScript decides which kind of data structure it wants, but you do have a lot of control to choose. So this is the practical application of this data structures, and it is, like, to be honest, it is the most important, like not most important, is the most asked question in interviews. If you go to any interview of the mang companies, they will ask you data structures. You are not going to run away from data structures, right? It is important because when it comes to programming, the logic of this data structures is what will make or break your application. The speed, it will decide the speed, it will decide your accuracy. All these things matters. And linked list always has the highest accuracy compared to any other programming language. It makes the least amount of errors because the addresses are manually stored. Each and every address is manually stored in each and every node. So retrieving might be slow, but it is always perfect. Okay, so the accuracy is more, the speed is less, quantity is more. That is the features of a linked list. Okay, so we have seen two, linked list, arrays. Now the third one is called a stack. Now I want you guys to think of a stack as, like, you guys have played that game, right? Jenga, or some kind of buying just books. When you keep one book above the other, you cannot retrieve the third book, right? Maybe if you like remove it fast, it might fall down, something like that, but you cannot remove something from here. Let me use a different color. Yes, yeah. So a stack is a kind of a data structure where you put things in a bag. Think of it like that. You put things in a bag, one above the other. So you cannot retrieve the lowest thing as long as you remove everything from the top, right? So that is what a stack is. Now in your memory, when it comes to programming languages, like in your operating systems, if you are using Windows or Linux, this is not in Mac. It is there, especially Windows or Linux. Your you any instruction you give, that is going to go into a stack. It is called as a data stack. Like if I go and click on something, that operation, before giving it to the CPU, it is going it into a stack, right? Before it was being used like a queue. A queue was always being handled this, but in today's iterations, it is always a stack. And the reason is stack is faster and logically less memory is required because this data structure is very cheap to implement. It does not require a lot of memory, right? You can see from the structure itself, we are not doing anything. We're just keeping a bag, putting elements in the bag, and you cannot remove the below one, right? As long as you remove everything above that, you cannot remove the below one. So that is a disadvantage of a stack. And these two words are, these are both the same thing. Last in, first out, or first in, last out, both pretty much mean the same thing. Which means whatever you put at the last, only that can be removed from the top. What you put at the starting, that can be removed only at the end. So that is the reason stacks are used. When you have that specific case, right? When you need some specific use case like this, only then you will use stack. This is a very less used in application software, but in operating systems, this is used directly. But when we programmers create a software on top, right, which works above operating systems, it's called application software. When we create that, stacks are not used that much. It's a specific use case, which, to be honest, there are no real world cases for that, which there. Okay. But in operating system, this is used inside your OS. Whenever you, for example, you're copying a file and then suddenly you go and delete another one. So it is not going to stop the copy, right? It is going to do both the operations. So how it is managing this? It's using a stack. It is putting the first operation in a stack and it is removing that. And it's putting the next one above it, right? So it will complete the latest one, then it will go back and complete the other ones. So that is the use of a stack. Okay. So we learned three things: arrays, linked list, and stack. Arrays and linked list are pretty similar and stack is the different one. Now the fourth kind of data structure is called a queue. This data structure is much more realistic. In everyday's world, all of you guys would have stood in lines for a movie theater, right? So this is how exactly it works. The first person who goes and stands in the line, they will be the first one to get the ticket, right? So exactly like that. A queue follows the principle of first in, first out. Whichever data you put first, only that can be removed first. So you can see from the diagram or the small representation we have done, you can only put data into a queue in one end. Okay, let me use a different color. Yeah. So you can only put data in one end. You can insert data over here. Inserting data into a queue is called enqueue. Enqueuing means you're putting data into the end, and the place where you put the data is called the tail. Okay, even in a queue, right? You go and stand in a movie theater. You will start from the ending. You will go and stand at the ending, then you will go front, right? Whoever is at the front, they will get the ticket first. Then after them, you will get. So whoever is entered first, they will get the ticket and they will leave, right? That person is leaving first. Then the second person is going. Then the third person is going. So the exact same logic you apply into programming. Now this is again used a lot in web development. So when we create buffers for some task, right? Like we want to do things one after the other. That is when queues are used. It is very common in buffering, in videos, in video rendering, all of these things. Even YouTube has a queue where it stores frames of videos one after the other. Because see, YouTube doesn't store videos normally. It needs a lot of, you know, asynchronous viewing. So every video is stored in a queue. If you look at a YouTube video, if a queue were not there, then 2, 3 people at a time cannot look at a video. That is the problem with servers. So to overcome that problem, YouTube has implemented a buffer queue. It's not the same like buffering which you see in YouTube. It's a different kind of thing. So we call this as buffers, where something is placed in the buffer and whatever is placed first, that is removed first. So this thing is again linear, right? All these four data structures that we learned right now, all of them are linear data structures. You put one after the other, and each of them has specific use cases. Like I told, the most common one is array, because that is general, right? You usually do arrays only. You do 10 items, you retrieve 20 items, you retrieve 100 items also is easily possible. Even if you see today's RAMs or registers, like they are in the essence of like say 10, 50, 16 gigs also is normal right now. So if a machine is has 16 GB of available memory, arrays are possible. You can store a lot of data in an array. So it is not a problem for that. But in older days when memory was not this easy, right? People had to make efficient use of memory. So even if we go into the lowest level of tasks that big companies like Instagram, Facebook and all their servers, efficiency matters a lot. So they have to put the most efficient data structure they can think of in the specific use cases. So all these four data structures that we learned, arrays, linked list, queues, and stacks, they have different use cases and the advantages you can imagine from their logic, right? So stacks and queues are extremely specific. They're only used when you need functionality like that, especially a stack. It is the least used data structure. A queue is used when you need the logic of finding which came first. So which you have to access first, right? So in your operating system, queues acts as buffers. So they are also present, but nowadays it's not used because we have dual core, multi-core CPUs, right? So we don't really use CPUs where only one instruction is fed at a time. We have multi-core CPUs, so we don't have to worry about that. But in olden days, CPUs could execute one instruction at a time. So what do? You use a queue. You give some instruction, the CPU will execute it. Then it will give the second instruction, it will execute it. So this is where queues will be used. Okay. So these are the four basic linear data structures. Now, apart from this, there are variations of this also. A queue, there is something called as a DQ, which is called as a double-ended queue. It is not the same as this DQ word. This DQ word just means removing items. But there is a D, just the word DQ, which is most commonly used in today's Java programming. This was not there when queues were released. It is a very latest addition. So a DQ is called a double-ended queue, where you can put items in the starting also, you can put items in the ending also. It's like a VIP queue, you would have gone to like standing in a line where a VIP person comes and he can enter in the middle, right? So that is a DQ. A normal queue is where the person who comes first and goes out first. D queue is like a VIP entry. You have a normal queue, but you also have a VIP entry where if a new very important person comes in, he can enter in the between only. He can go before you. That's a D queue. So these are the four uh, linear data structures we most commonly use in Java. So let me just erase this. So this finishes the linear data structure part. Now, as I told you, the other part, which is non-linear data structures, it is not based on how you actually put data. It is based on what logic you need for this data. Okay, because this data structures are logic based. You only use them when the logic defines it. So we most commonly use two things, trees and graphs. There are in today's time there is another specific one which is the like combination of tree and graph. Okay, it's called TRs. We don't use it in normal programming. It is used in web development. So there is a specific protocol called TRPC, which deals with GraphQL. So that is the most latest iteration that is used in today's industry also. But to learn GraphQL, you should understand what is a tree and what is a graph. So let's look at these both data structures. Now, from the name itself, it is non-linear, right? Like I told you, linear is something that is stored one after the other. Non-linear is more based on what exactly the data requires, because it is not just about storing one after the other. Sometimes you're not retrieving a list of 10 things. You're maybe retrieving like in a company, right? Take an example of a company. If I want the list of all the employees along with their powers, for example, think something like think some access. Some employees have access to third floor, some employees do not have access to third floor, something like that. I cannot easily represent in a linear data structure, right? Because there is so much more memory, so much more meaning for this data. So instead of using a linear data structure, we can use a tree. Now, a tree is a hierarchical data structure where each and every level has a specific hierarchy or it has a meaning. Okay. And the tree again in direct Java, we don't use trees too much. We use a variation of a tree called a binary tree. But first, I want you guys to focus on what a tree is. Now, this example in the photo I've shown is an exact best binary tree. But a tree might not just be like this. Okay, in Java, binary trees are mostly used. But if you think of programming in other languages, a binary tree is yes, it is used. It is the most common use, but it is possible to use other kinds of trees also. So I want you guys to just think about a hierarchical data, like something like this. So there are multiple levels, right? So we can represent maybe a company like this. The topmost, there are the CEOs and executive or those, board of directors. Below them, you have your first VCs, your VP, and all those things. Below your VCs for a particular uh, field, you have again managers. Right? You have IT manager maybe over here, then you have something like HR manager, and many things like that. So this is the reason we use a data structure like a tree. Now, if I just write all these things in a list of things, it can be possible, but there's no meaning for it, right? A person by just seeing a list of things, he will not understand like the CEO is the biggest person. Below him comes the VP, the VC, board of directors, anything. So this hierarchy, if you want to logically represent data that is hierarchical, you will be using a tree. Now, trees are very widely used when it comes to retrieving personal profile information. We call this as profile information. Now, when you go to something like uh, nowadays, the social media is not used. This particular Orkut, I don't know if you guys remember or not. Before Facebook became popular, there was a social media network called Orkut. Orkut was completely based on tree data structures. They used the logic of trees, where one person can have multiple friends, right? In Facebook, it's like one person can have friends and many people can add them. But in Orkut, it was different. It's like you follow that person, you become under them, and you can have more followers. But if you both follow each other, there is a specific different thing. You become friends. So that's how Orkut was based. So Orkut always used trees in its background. Okay. So this representation of data that is supposed to be logically hierarchical you can only achieve using trees. Trees are the ones which are used most of the time in logical scenarios. Okay. Now, I don't want you guys to worry about binary trees like it is something different, because binary trees are practically the most used trees, because we use trees for one very specific purpose, that is searching. If you have data, like for example, 20 or 30,000 data, it's tough to search in an array, even though you know the location. For example, I have 20,000 students and I want to retrieve a student based on their name, not based on their roll number. But names can be same if they're not alphabetically arranged. Say, for example, they're not alphabetically arranged, they're randomly placed, and students have roll numbers. So if you don't know the roll number, how do you search them? You have to check each and every value, right? Whether it's right or not. Instead of that, you can convert your data structures into a tree. So then you can retrieve things faster. Right? This is used for searching things. It's called a binary search tree. So let me just clear this. So first of all, a binary tree is a tree that can maximum have two children. It cannot have more than two children. So what do I mean by this children? So in this tree that I just showed you, you have to know some specific names for these things. Say, for example, there is a tree like this. Okay. So this first thing is called, use another color. Yeah. Okay. So this first one is called a root node. Again, this node is always common. The name node, we always use it to represent a particular data point. Okay. So this first element in a tree, we can call it the root node. Everything below, we call it the root node's children. So this second node over here, let's give a name like 2, and this is the name 1, for example. So 1 is a child of root node, 2 is again a child of root node. And this things might again have more children. Okay, 1 can have more children. It can have like how many children it wants. So this again becomes like A, for example, this is B. So B is the child of 1, 1 is the child of root. That is how you can understand things. This forms a hierarchy, right? Now, if you think of your families only, there is something called as family tree, right? If you want to show your grandparents and parents, it becomes a reverse tree where for example, take you will have two parents, a father and a mother. And your father again will have two parents, their grandparents, and a mother will again have two grandparents. So now we are increasing. So when you want to represent your family tree, you use a reverse tree. Such a logical example I've given you. So this hierarchical data is common. In real world, hierarchical data is really common. We might logically think that it's a very small use case, but hierarchical data is really common. Okay. So a tree with more like maximum two children is called a binary tree. So this binary trees are used for searching things. Now, why? Why do we use binary trees for searching? Let me clear it again and I will make a new thing. Okay. So why is it better for searching? Because it gives the functionality of removing an entire part. If, for example, the element which you want to search is not present in 2, you can completely remove this entire part. So you're removing a place from which you have to search. So I want you guys to think of, like, for example, you're in a school. Okay, and you have two buildings, and you know the person cannot be in this kind of classroom. Like one classroom has circle classes, one classroom has square classes, and you already know the person will only be in square classes. You can exclude the entire building, right? You don't have to waste time searching that building. So that is the logic behind a tree. You are going to exclude an entire subtree logically. So it becomes faster for you to search. That's why binary search tree is very common as a searching algorithm. Okay, tree traverse algorithm, we call it. It is a very fast and common algorithm. Now, it is not easy to compare non-linear and linear data structures, right? Trees and arrays, if you compare them, it does not make sense because they're completely different use cases. You can compare it, arrays and linked lists, but trees and arrays are tough to find advantages and disadvantages because they're completely different use cases. So instead of comparing trees and arrays, we'll compare trees with its own family, that is nonlinear data structures. So after trees, we have something called as a graph. Now, a graph is, in practicality, it is really useful because I will give you a use case right now. Say, for example, you guys want to find the direction between 4 or 5 points. Like you want to first go to a shop, buy something, then go to a second shop, buy the second item, and come back home. So this road you go, right? It is coming from a graph. If today you go to Google Maps and you maybe took not just two endpoints, you put more stops in between, right? You can do that. You can find the direction between just more than one. So Google internally uses a GraphQL algorithm to find the shortest distance between 2 points. So this thing of finding shortest distance, finding the least weighted distance, all this thing is the applications of graphs. Graph is the most practically used data structures when it comes to either web development or even data science. We use data science graphs when we are associating data. So this is really important data structures in real world. Okay. It has a lot of specific use cases, but overall it is really important. So in graphs also, first thing you need to understand is it is non-linear because we don't care what is next to each other. We just store things and then we have a direction which is going where or which is next to where. So we have this kind of directed, or it can be undirected also, but you have to understand that there is a difference. Like I'll just show you from the diagram itself. Here you can see the graph, right? A, B, C, D, E. This specific graph, I'm talking about the one here. This graph, if you see A and D, there is no connection. And E and C, there is no connection. There's a specific reason for this. So this is a logical graph where you're saying if a person is starting from A, he can go to B, he can go to E. But this person in A does not know what is D and C. So that is the use of writing a graph like this. So graph again is a specific use case, but since in practical use cases there are a lot of examples, so it is a bit more used than a tree. Okay, there are some terminologies in a graph you need to learn. First is this edges and vertices. So these endpoints which you see A, B, C, D, E, we call them as vertices. This is just use highlighter out. Yeah, this is better. Okay. So this vertices, you see the endpoints A, B, C, D, E, they are called endpoints or vertices. And this lines, sometimes you can even call them edges or you call them direction. There are many words, but describing way these are called the endpoints which you have to traverse through. Like if you think of Google Maps with the example I gave you, you will be going from one endpoint to the other, and maybe you need to make some stops. But you are not going to go from one to the last point, right? You do not need that road. Like if tomorrow I go to Google and I want to go from A to B to C. Now Google will not care about A to C because we have not asked that. It will only care about A to B and B to C. That is the reason for graphs. If we were not using graph, if we go to something like arrays, it is not possible. But think is very costly to use arrays in this scenario. So think we are using arrays. We are storing the value, how much this is there in an array, how much this is there in an array, then what is the direction of this, what is the value of this, all of things you have to store. Instead of that, what Google is doing, it is making a graph QL. It's called a GQL, a graph QL. It is making a graph QL which stores ABC as endpoints. And this middle directions from going from A to B and B to C are called vertices. So it stores these things in actual memory. It is a very practical data structure. Okay, but it is really complex because there are so many use cases for this. There are so many algorithms on this. So if you go researching more into graphs, right, you will come across a lot of algorithms. That is like searching algorithms like BFS, breadth first search, or you have DFS, depth first search. Then you have some algorithms that can find a point. like Dijkstra's algorithm. You guys would have learned it if you learned some programming language. So there are many algorithms in graphs. Okay, graphs is it's a very broad field. So in graphs also, you see these lines, right, connecting A and B. You can see these two diagrams which I'm showing. The first one has a arrow. So when you have an arrow from one point to another, you're showing this graph is directed. That means A will know the position of where B is, but B doesn't know A. It's a directed graph. In an undirected graph, A will know B and B will know A. But in a directed graph, A will know about B, but B will not know about A. This is not possible because it is directed. You can only go in one direction. Okay. So that is the use of graphs. You use graphs when you have this specific need of arranging items in an order. Like you want to do things in an order, and there are some certain relationships between items, and every item is not related to each other. So you want to specify something like that, you use a graph. And most of the time, right, there is something called as a matrix, a directional matrix for a graph. So using a graph is represented using this kind of matrix. So this is called as an adjacency matrix. So from here you can find out that A and B are from A you can go to B. Wherever one is there, that means A that is adjacent to A. So from A, B is there. From A, you can find E. From the graph you can find, right? From A you can go to E and you can go to B, but you can't go to C, you can't go to D. And sometimes some graph might have its own cyclic also. It can be like this. That time this also will be one. Okay. So why I'm emphasizing so much on graphs is there is so much more content in graphs and it is used a lot more than these other data structures. And it is complex also because it is used in so many different ways. Google uses it as a GraphQL algorithm. And if you go to APIs like your phones today, when you have apps, right? Data shared between an app and a server is always in the form of other than REST APIs, it is always a form of GraphQL only. So GraphQL is really common in today's web development world. So you have to understand that graph is a directional, it can be optionally directional, and it specifies the relations between specific elements. Like A is related over here in this example, A is related to B and E, but A is not related to C and D. This is how you understand the graph. From A, you can go to B. From A, you can go to E, but you can't go to C and D. Okay. That is a use of graph. When you have something like this, when you want to do something like this, you can use graph. Okay. So this is the like just a second. This is a use of all these data structures, and each of them have the specific uses which you want to use. You can, according to the use case, the advantage is this is far away. Okay. According to the use case, the advantage is to be set. Okay. So I guess that completes all the data structures. So I want to just once go and show what all we saw. So from linear, we learned four things: array, stack, queue, and linked list. From non-linear, we learned trees and graphs. So this is the most common used data structures in Java. There are more that are built on top of this. If you come across any other data structure in today, that's a combination of, like I told you, trees and graph can be TRs. Then double-ended linked list is a combination of queue and the linked list. So these kind of things are combinations are built upon these initial data structures. Okay. So this is a small introduction of how you can learn data structures, why they are used, and which data structure is useful in which scenario. So that is it for the content. Now, if you have any doubts related to, you know, any of the part I taught, you can ask me right now. Yeah.
Guys, you can raise your hands or use the chat box to type in your queries.
Okay. So that's good that you don't have any doubts. I hope everyone understood this. Because when you go into interviews, every interview there will be data structure. And it's a very important concept according to that.
Guys, you can ask any query if you have or anything about the interviews, how to go ahead. You can suppose. Okay, I see no questions. So thank you, Nitish. Thank you for an awesome session and like such insights which are very useful for the students as well as the students who are looking for a job or probably looking for DSA more into detail. So thank you so much. And others just
My
stay back.
pleasure.
Yeah,
Yeah.
others just stay back. We'll be going ahead with something which we have planned for you. Okay, Nitish. Thanks for connecting.
Thank you.
All right, guys. So just fill the particular form which has been posted in the chat box to receive your ebook copy about this particular webinar and how to go ahead in terms of data structures. Uh, Apart from that, I just wanted to give you an overview about the website. So just hold on. I'll just show you how the website and the portal looks like, so that if there are more such upcoming webinars, you can simply check the updates and join in with us. So I would first like you all to go to Play Store and download SkillVertex app. So I'm just typing the spelling as well over here, SkillVertex app on Play Store. Okay. And just turn on the push notifications so that you get daily updates of the webinars. We have a webinar every Saturday. So yeah, that's about it. I'll just share my screen and show you how the website as well looks like so that it's better for you to understand. So this is our website, skillvertex.com, and once you sign up and enter your OTP, I hope my screen is visible to you all. Can I get a thumbs up or chat box reply? Is my screen visible, guys? Yes. Okay, great. Thanks, Nikhil. So this is how the website looks like, and these are the various categories of courses which we have. In case you want to learn more from mentors like Nitish, you can just contact our team and get enrolled for any of these courses if you want to. And yeah, we also offer some advanced courses as well. We also have advanced courses in MERN stack development, DSA, which is also integrated with Java. And yeah, these are the new courses which we have launched as advanced courses, and they will also have the placement assistance as well. So yeah, you can simply reach out to the team and let us know if you would like to be a part of our community as well. So thank you so much for joining. I hope you have filled the form to receive your ebook copy, which is free for you guys. There are no charges for it. So just like fill up the form and get your copy on your mail. Now I can see there are 3 people who have filled it. So others, please go ahead and quickly fill the form for receiving your ebook. Just quickly fill the form, guys, so that we can wrap up the session as well. Let me know once it's done on the chat box. Everyone has filled the form. I would like a reply in the chat box. Those who have filled the form can simply acknowledge it as done. Okay, those who have filled the form just acknowledge in the chat box. Those who haven't, please go ahead and fill the form. All right, guys, thank you so much for joining. I hope you were able to, get your key takeaways from this particular session. And if you like to have more such sessions, please, download SkillVertex app and, turn on the push notifications so that you get to know about the daily updates which we have, and if there are more such sessions for you guys, so you will be able to attend them. Okay, thank you so much for joining, and we'll see you next time, hopefully.